Betelgeuse, a captivating star located 642.5 light-years away from Earth, is one of the most intriguing celestial objects in our visible sky. Known as the Shoulder of Orion, this red supergiant has fascinated astronomers for centuries. With a surface temperature of about 3000 Kelvin and a lifespan of millions of years, Betelgeuse is now in the final stages of its life. Having exhausted much of its fuel, it has burned through hydrogen at an extraordinary rate. In recent times, its outer layers have begun to behave erratically. The star has dimmed, brightened again, and expelled material into space. This strange activity has led scientists to speculate about its potential transformation into a supernova. But here's the twist that changes everything. Because Betelgeuse is over 600 light-years away, the light we see from it today left the star over 600 years ago. In simple terms, Betelgeuse could have already exploded, and we wouldn't even know it yet. The light, which travels at the speed of light, is still making its way toward Earth. This delay transforms a future event into a present uncertainty. And as we look at this red supergiant nearing its end, the question arises, how will we know when it reaches its final moment? When a star like Betelgeuse reaches the end of its life, it doesn't fade quietly. Instead, it undergoes a spectacular process called a supernova. This is the ultimate event in the life cycle of a star, a massive expansion, followed by a burst of light and energy that can briefly outshine an entire galaxy. In the case of Betelgeuse, this explosion could release more energy than the sun will emit throughout its entire lifetime. But what does this mean for us? Betelgeuse, situated 642.5 light-years from Earth, is far enough that any event we observe from it today has already occurred. The information we receive is always delayed, and as a result, we are seeing the star not as it is now, but as it was centuries ago. Tonight's view of Betelgeuse is the view from over 600 years ago, when the light first began its journey across space. This means it is entirely possible that Betelgeuse has already exploded, but the light from that explosion has not yet reached us. This presents a fascinating reality. The explosion could be in our past while still being in our future observationally. The significance of this delay is twofold. First, the explosion's effects may not reach us for centuries. And second, we may not even know about it until the light finally arrives. From our perspective, Betelgeuse is already a historical image. Its light traveling across space at a speed that takes over 600 years to reach us. This delay adds a layer of mystery to our understanding of cosmic events. We are not merely observing the present star, but a version of it from the distant past. And when the supernova finally occurs, we may not be prepared for the dramatic effects it could have on our planet. The future of Betelgeuse is uncertain, but one thing is clear: its end will not be subtle. As it nears the end of its life cycle, the star will expand significantly. This process is characteristic of red supergiants, which use up their hydrogen fuel more rapidly than smaller stars. Betelgeuse, having exhausted its hydrogen long ago, will undergo a transformation that could result in a Type II supernova. Depending on the conditions, it could even collapse into a neutron star, or, in some cases, become a white dwarf. But the critical question is not whether Betelgeuse will die, it's when, and because of the vast distance, we will always be years, if not centuries, away from knowing that moment. The erratic behavior of Betelgeuse's outer layers, especially its fluctuations in brightness, has kept astronomers on edge. These changes have sparked ongoing discussions about the star's potential demise. As Betelgeuse continues to burn through its fuel and exhibit irregular behavior, its future remains a subject of intense study. The star is behaving unpredictably, leading some to speculate that a supernova could be imminent. In 2021, scientists made an alarming discovery. The star underwent a significant dimming, followed by the release of an immense cloud of material. This event raised questions about the star's future, as such behavior is not typical for a star in the final stages of its life. The dimming was so dramatic that it triggered widespread attention among astronomers. As one of the closest red supergiants to Earth, Betelgeuse offers a rare opportunity to study the late stages of stellar evolution. Its erratic behavior has become a focal point for understanding how massive stars evolve as they approach the end of their lives. The 2021 event that led to Betelgeuse's dimming was unlike anything observed before. Scientists determined that the expelled material was moving at speeds of over 200,000 miles per hour, roughly 320,000 kilometers per hour. This discovery was critical because it helped explain the dimming effect. The material expelled by the star temporarily reduced its visible brightness, creating the impression that Betelgeuse was fading. The cloud of material formed in space, condensing in the cold vacuum and suppressing the motion of the particles. This phenomenon provided scientists with valuable insights into how material behaves when expelled from a star. In space, the particles cool and condense quickly, limiting their ability to expand further. This explanation gave astronomers a better understanding of the mechanics behind stellar explosions and how such events unfold in the cold depths of space. While the dimming did not confirm an imminent explosion, it underscored the fact that Betelgeuse is undergoing significant changes. The star's behavior was no longer just a subject of theoretical discussion. It was a tangible, observable event. The material expulsion and the subsequent dimming event presented a new puzzle for scientists. The star was no longer behaving in predictable ways, and its fluctuations in brightness seemed to signal that it was nearing the end of its life. The event, while unsettling, provided an invaluable opportunity to study the final stages of a massive star. Betelgeuse had become a living laboratory, offering a front-row seat to the processes that occur as stars evolve and die. Its proximity to Earth made it one of the best subjects for this kind of study. The dimming event highlighted the complexity of stellar life cycles. A star's behavior as it nears its final moments is not always straightforward. In the case of Betelgeuse, the dimming was not an isolated event. It was part of a broader pattern of irregular activity. The star was undergoing a transformation that was both observable and significant, and scientists had to consider the possibility that the star could be on the brink of a supernova. Even though the likelihood of a supernova occurring in the immediate future remained uncertain, the data collected from Betelgeuse was invaluable. The star was offering a rare opportunity to observe the dynamics of a red supergiant as it neared the end of its life cycle. Astronomers were carefully monitoring every fluctuation in brightness, every shift in the star's behavior, to gather more clues about its impending fate. The potential magnitude of a Betelgeuse supernova is staggering. If the star were to explode, the resulting burst of energy could release more light and heat than the sun will emit throughout its entire lifetime. In fact, studies suggest that a supernova of this scale could briefly illuminate an entire galaxy. For comparison, the explosion of the nebula RCW-86, observed by Chinese astronomers in 1054, was so intense that it was visible during the day. The brightness of that explosion was so extreme that it could be seen even in daylight, a testament to the incredible power of a supernova. If Betelgeuse were to go supernova, the resulting explosion would outshine anything seen in human history. The energy released would be incomprehensibly greater than the atomic bomb explosions of Hiroshima and Nagasaki or the Chernobyl nuclear disaster. While these events were devastating at the planetary level, they pale in comparison to the scale of a stellar explosion. A supernova is one of the most powerful events in the universe, capable of releasing radiation that could destroy entire planets in the blink of an eye. The comparison to human-made nuclear explosions serves to put things in perspective. While nuclear events on Earth are catastrophic, they are small in comparison to the scale of natural explosions in space. Stars like Betelgeuse have the potential to release far greater amounts of energy than anything humanity has ever experienced. The supernova that occurs when a massive star reaches the end of its life is a natural event that dwarfs any man-made explosion. And the intensity of such an explosion is so great that it can briefly outshine an entire galaxy. While the explosion itself would be incredibly bright and powerful, it is not the only aspect of a supernova that scientists are interested in. The energy released by a supernova can also have far-reaching effects on the surrounding environment. For example, radiation from the explosion could potentially trigger geomagnetic storms on Earth. These storms could disrupt electrical grids, satellite systems, and even GPS systems. The effects of such an explosion on Earth's technological infrastructure could be significant, even if the physical impact is less severe. The concern is not planetary destruction, but rather disruption to the systems that we rely on every day. As scientists continue to study Betelgeuse, they are preparing for the possibility that the star could soon enter the supernova stage. One of the key signals that researchers are watching for is the arrival of neutrinos from the direction of Betelgeuse. Neutrinos are subatomic particles that are produced in large quantities during a supernova explosion. Their detection would be an early warning that the explosion is imminent. However, even after the initial burst of energy, the aftermath of a supernova can be visible for years. The remains of the explosion would continue to be visible in the sky, gradually fading as the light dims over time. Despite the uncertainty about when the explosion will happen, the impact of a supernova would not be limited to just the physical effects of the explosion. The social and psychological effects could be just as profound. Humanity has a long history of reacting with fear and confusion when confronted with unexplained celestial phenomena. A supernova, as bright as Betelgeuse's explosion, would undoubtedly provoke widespread panic and speculation, especially among those who are unaware of the scientific context. Public reaction to such an event would likely include confusion, fear, and even hysteria. This is why the document emphasizes the importance of knowledge in understanding such cosmic events. By being informed about what is happening, we can better prepare for the inevitable reaction when the supernova does occur. The explosion itself may not pose a direct threat to our planet, but the psychological impact could be significant. Fear and misunderstanding could spread quickly, and it is crucial that we approach this event with a clear understanding of its true nature. Betelgeuse is not just another star in the sky. It is a massive red supergiant in the final stages of its life cycle. Its irregular behavior has already caught the attention of astronomers, and the potential for a supernova is a real possibility. What makes Betelgeuse even more fascinating is the delay in the light we observe. Because the star is so far away, the light we see today is a snapshot of the past. It is possible that Betelgeuse has already exploded, and we simply have not received the signal yet. The delay between the event and our awareness of it creates a unique situation where the explosion could be both in the past and in the future. We are observing a dying star from the distant past, and when the explosion occurs, it will not be a surprise to those who understand the science behind it. It will be a natural culmination of the star's life cycle, a process that has been happening for billions of years. When the supernova does occur, it will be a spectacle unlike anything humanity has ever seen. The explosion could be visible to the naked eye, brighter than the full moon and lasting for years. It will be a cosmic event that will capture the attention of the entire world. But the impact will not just be physical. The social and psychological effects of such an event could be just as profound. In the end, Betelgeuse's supernova will be a reminder of the immense power and beauty of the universe. It will be a natural event that marks the end of a star's life and the beginning of a new chapter in our understanding of the cosmos. Whether the explosion occurs tomorrow or centuries from now, it will remind us of the vastness of space and the incredible processes that shape our universe. And when that light finally reaches Earth, whether it happens in our lifetime or far beyond, it will not be a surprise to those who understand what is happening. For those of us who study the stars, the death of Betelgeuse is inevitable. The only uncertainty is when we will see it happen. If you want to stay informed about real cosmic events that could reshape our understanding of the universe, make sure to subscribe and activate notifications. The next signal we receive from deep space could be more than just light. It could be history arriving 642 years late.